Okay guys, quarantine video day 1. This is for Monday, March 16th. This is for my regular Algebra 1 classes, first period and 9th period. So since I'm combining both classes into one, we kind of left off on different spots. So some of you already have these notes down, some of you have part of the notes down. I just decided to redo all of them for this first one. So we started talking about quadratic functions back when we were in session. Quadratic functions are the third main function that we do in Algebra 1, behind linear functions and exponential functions. Okay. So before I talk about quadratics, I do want to talk about linear and exponential again, just a quick refresher. Linear functions are linear, obviously, appropriately named. The standard form for a linear function and again, we had one called standard form where it was ax plus by equals c. But the typical form that we used was slope-intercept form, y equals mx plus b. And then I want to remind you about the shape of the graph. All linear functions are lines, or straight lines, I guess. All lines are straight. Okay. And that's what we did almost the entire first semester, linear functions. The second type of function we talked about was exponential functions. Exponential functions were nonlinear. Remember, these were the growths and the decays. So it's a nonlinear function. The standard form for exponentials was y equals a times b to the x power. Okay, remember, what made it exponential was that there was a variable in the exponent. And then the shape of exponential functions, remember, these were the growth and the decay curves. Okay, so growths started slow and then rose very quickly. Decays dropped very quickly and then kind of leveled off. What we call that shape is it's a single directional curve. So if it was growing, it was always growing. If it was decaying, it was always decaying. It never changed direction. It's a single directional curve. All right, so let's apply all the same information to quadratics. Quadratics are also nonlinear. The standard form for a quadratic is y equals, or we'll say f of x equals, it's ax squared plus bx plus c. That's going to be our standard form. Now, what makes something quadratic is the squared part, the x squared. Let's write down standard form first. So every quadratic is going to have an x squared. Okay. Now, the bx and the c, some have them, some don't. It just depends on the quadratic. Okay. So that ax squared term is the important one. That's called the quadratic term. And one thing to note is that a can't equal 0. If a equaled 0, that would be 0x squared. We know anything times 0 is 0, and that x squared term would go away, making it no longer quadratic. Okay. The bx is the linear term. And then the c is the constant. So that is standard form. Now the shape of a quadratic. The shape of a quadratic is called a parabola. Kind of a weird name. All quadratic functions are parabolas. Okay. What a parabola is, it's a U-shaped graph. Okay. It does change direction. Some start decreasing, and then eventually it'll start increasing. Some increase and then decrease. But there's always one direction change. All right, let's look at the graphs of all these together. Oops. So I'm just going to draw a quick XY chart. Now we know linear functions are just, the parent function for a linear was the main diagonal going through the origin. Actually, let's do it in red. Okay. Linear functions have that constant rate of change, that slope. Exponential functions, again, had the curve. If we're just doing 2 to the x power, we'd have 0, 1, negative 1, up a half, 1, 2, 2, 4, and 3, 8. Do my best to draw this curve. Okay. And again, exponentials growth started slow, but then raised really fast. Okay. And then the quadratic, we're going to talk more about graphing in the next section. Okay. Quadratics are U-shaped. Okay. They're also symmetric. Get rid of this. Now again, you don't have to draw this perfectly right now. We're going to learn how to graph it in the next part. And they're kind of tricky to draw at first, but we're going to draw a lot of them over the next couple weeks. All right, now right away, it looks like quadratics grow faster than exponential functions. As far as the growth goes, linear functions are going to be the slowest, followed by actually quadratics, and then exponentials are always going to raise the fastest out of all three of these. All right, now, like I said, I already mentioned quadratics, that U shape. That U shape is symmetric. So all parabolas are symmetric around a central line. And that central line has a special name. It's called the Axis of Symmetry. All right. So it's called the Axis of Symmetry. So what that means is everything on one side of the line is also reflected onto the other side of that line. And I usually abbreviate the axis of symmetry as AOS. So you're going to see that quite a bit. All right, so let's talk about the axis of symmetry in a little more detail. All right, the axis of symmetry, it's always going to be a vertical line. Now, technically, this kind of as a side note, parabolas can also go sideways. Okay, we don't deal with sideways parabolas. Parabolas that open left and right in algebra 1 because they're not functions. They would fail the vertical line test. So our parabolas are always going to be opening up and down, and therefore our axis of symmetries are always going to be a vertical line. It's going to be a vertical line at x equals c for some number c. Okay, so x equals 1 or x equals 2. Remember, if you have an equation that only has an x value, it's going to be a vertical line. Okay, only y is going to be a horizontal line. Now, the axis of symmetry is not a real line. It's not actually on the graph. So when we graph it, we usually use a dotted line. So it's not part of the graph at all, but it's more of a reference point. So when we graph it, we're going to graph it with dotted lines. All right, now the axis of symmetry only intersects the parabola at one point. So the axis of symmetry only intersects the parabola at one point. Okay. And that point has a special name. That point's called the vertex. The vertex is one of the most important points on a parabola. The vertex is where the graph changes direction. Okay, where the graph changes direction. And that vertex is always either going to be the highest point or the lowest point on the graph. Okay, now when we talked about features of graphs, we know the highest point on a graph is called the absolute max. And the lowest point would be the absolute min. Okay, so the vertex is always either going to be the absolute highest point or the absolute lowest point. So we'll say it's always either the highest or lowest point. Lowest. And again, the highest point is called the absolute max. And the lowest point is called the absolute min. All right, I think that's probably a good place to stop for now. We'll start slow with these videos. Tomorrow we'll talk about actually graphing them, how to find axis of symmetry. But this is just the basics of parabolas, of quadratic functions. You got the axis of symmetry. You got the vertex. We know it's U-shaped, called a parabola. We know quadratics always have x squared in them. And that's about it. All right, guys. We'll pick this up again tomorrow.